All right, should be live. Hello, everyone. It's been a while. There was a lot of installer stuff to work on after the release. I don't know if you saw. There was I think 20 or 30 releases that happened there, and then a lot of dealing with Apple bugs and randomness. But it's time to get back to kernel coding. So I sent a pile of patches a couple days ago. And one of them was adding the PCI power-enabled GPIO stuff, and that sort of brought up some discussion about how that should be implemented, and that gave me some ideas as to how I should move forward on that. So is the audio video all that fine? It's just been a while. So also I changed the way I do audio on this. It's on a different machine now. It's on the streaming machine now instead of my main machine now. So we won't have the issue with the audio cutting out when I was compiling. That used to happen sometimes. So hopefully that also improved. Yeah, good. Audio is great. Video is great. Excellent. So yeah, let's look at that. So yeah, I just sent out CPU Freak, which hopefully won't be too controversial. V1 was a bit weird in how it was done, and this is like a complete rewrite. Oh yeah, also I'm gonna get some water because I'm already getting thirsty. As I had lunch earlier, no drinks. I'll just be 1 minute. Back. The Pute says, "Don't get hacked by Lena this time." Yeah, I don't know. She I think apparently she managed to steal my stream key somehow, and I'm not sure how that happened. So we'll see. We'll see if she tries anything weird again. But she said she wouldn't. So yeah. So CPU Freak is done, and now it's time to look at PCI power management. So what I actually want to get done today is that on the M1 Pro Max laptops, the SD card is on a PCI SD card controller, and it has a power-enabled GPIO, which right now we just turn on like unconditionally. But there's actually a GPIO on the PMU that also is connected to the card detect. So you can detect if a card is plugged in or not, even with the SD card controller powered down, I think. So the idea is that in theory you should be able to literally shut down the entire SD card controller until a card is plugged in. And that'll be a good test for this feature, but also this whole thing also ties into going into sleep mode and other stuff. So even if, by the way, I think macOS doesn't do this yet. So this will be some power management that Linux does that macOS does not. Again, reminder that, we can do things better than Apple sometimes. So, but also this ties into sleep mode and other stuff. So it's good to get it done. It'll be a proof of concept of how this ties in with the PCI subsystem and the device tree bindings. So in the ongoing email discussion, Rob mentioned that it shouldn't be declared as a GPIO. It should be declared as a regulator, which itself, there's a generic regulator that'll just talk to a GPIO. I think that makes sense because on a different platform, this could well be driven by not a GPIO, but say a voltage rail on a PMU regulator, which would be exposed this way. So I agree with that premise. So we're probably going to change it to use a regulator. However, we were arguing about whether the regulator should be declared in the. Actually, I can show you. I can find that. So right now, the way it's done right now is in here. And I'm in the wrong branch. Minus that main. You go to Linux. Check out Asahi. So right now, the way this is done is we have the SD card reader here. It's port 01. And has a PDE power-enabled GPIO. And this is in the port. So this is in the PCI Express port. And the way this is actually, it's a bit confusing because it's broken into two files. But so the way this is done, if you can see that here, is that we have a PCI controller. And this is also another weird Apple thing because I think every single other ARM platform out there with PCI controllers has a single port per PCI controller. Apple has multiple ports per PCI controller. So we have a kind of weird nesting what doesn't really exist on any other platform, and stuff is broken up into two levels. So we have one controller, and it has a bunch of global stuff, and then it has multiple ports, and each port has some per port stuff. This needs to go away, by the way, maxing speed. And then these devices get inserted into these ports and they declare the SD card device, which, by the way, needs a compatible. It doesn't have that yet. I should figure that out. Need to do an LSPCI. And so we were arguing about whether this GPIO business should be in the port or should be in the device. And Rob said it should be in the device because it could have something to do with power sequencing and other nonsense. But that is very weird in my view because first of all, the device can't even be probed until it's turned on because the PCI core won't find it. So Rob said something like, look for this node and sort of always probe it if it has this compatible, but that just seems weird. And also the concept of a slot or a device getting powered down is actually part of the PCI standard, not the mechanism. That would be usually ACP on systems with ACP. But the idea that you can turn off PCIe devices is in the PCI spec. So I think it makes sense to declare a regulator in here, in the port. Whether that should be part of some kind of standard binding or not, I don't know. I don't particularly care about that. But I think this is where that belongs, because then that can hook up into the PCIe driver, that's subsystem, and it would know to turn it on startup and to turn it off when the device is going to go into the D3 cold state, which is the shutdown state, which is a thing that ACP systems can do. Yeah, the compatible is the PCI vendor and product ID. The bus segment number is part of this reg, I think, is how that's done. It should be this, I think. And also it's this bus range thing. Honestly, like the PCI DT binding still kind of baffle me sometimes. But yeah, I think that makes more sense here. So I'm going to argue for that, but we are going to switch it to a regulator because that is the more correct way of declaring a power consumer in DTs than a GPIO. So, yeah, and I can see how that would work for some systems. So we're going to go with that. So there's a bunch of things that need to happen to make this work. First I need to prove that SMC GPIO actually works, as if it doesn't, we're wasting our time. At least in using it for the SD card reader. At least for the hot plug stuff. It'd still be useful for sleep. So I'm going to test that in Mini first. 2, we need to implement that in the SMC GPIO driver because it doesn't support interrupts yet. It shouldn't be too hard though. I also need to look at how that works with GPIO controllers. I forget if there's a GPIO specific API for requesting interrupts, or whether we actually need to actually like map it. through an interrupt controller, but yeah, I'll find out. Then the second thing that needs to happen is we added regulator here and we declare it, and we make the PCI core at least turn it on so far. Then PCI hot plug needs to be implemented, and Sven mentioned has a little proof of concept of that. It apparently isn't very hard, so we can just do that. And then once that's done, that needs to be hooked up into the PCI like D3 code stuff, so that the PCI core knows how to turn it on and off when required, and also on sleep and all that. And finally, the SD card driver needs to actually look at. We need to add another GPIO. We need to add the card detect GPIO, which I think is already a standard thing on SD nodes, because right now it's using the internal card detect, which is why it has the CD inverted thing. So we would replace that with an external GPIO, and that would allow we'd have to write the support for this, but it would allow the SD card driver, the SD controller driver, to see, oh, I have a GPIO, which is external, so it doesn't depend on this device being turned on. So I can enable PCIe D3 code and runtime power management, and that means that when there is no card inserted, the whole thing can turn off. And as long as the power management is done and the save restore is done properly, when a card is inserted, the GPIO triggers an interrupt, and then that tells the SD driver to take the device out of sleep mode, which powers it on via the PCIe subsystem, which then allows the SD card driver to restore or reset it or whatever it has to do, probably just reinitialize. And so there's this whole pile of things that have to work together. And nothing is particularly complicated, but also if this whole thing works, for unplugging and plugging in cards, there's a good chance it will also just work for sleep. And then I can disable the Wi-Fi, which I actually am going to do right now, because I don't need it right now. Just by getting the power enabled, it'll definitely stop working. And if that's done, and given we already keep PCIe buses turned on in sleep mode, that should actually make S2 idle work, even with PCIe and the SD card controller, with correct shutdown of the SD card controller in sleep mode. And then if that works, what's left is fixing Wi-Fi, which is a whole different can of worms, because Broadcom has some interesting ideas about power management, which aren't the same as the ones that Apple uses, aren't the same ones that the driver uses. So there's reverse engineering to be done there. So that'll definitely not happen today. I won't have time for that. But when that's done, I think at that point we can actually enable S2 idle sleep modes for users. And reminder, S2 idle is not true sleep. It's not full system sleep mode. It's basically sort of software sleep mode, where like the software stops running but the kernel is still alive, and the CPUs would still be non-deep mode, so it wouldn't actually save a ton of power over having the system idle, but at least it would shut down devices, and it would have the advantage of at least making sure your software isn't running, right? So you can like throw your laptop in the bag and know that it's not going to cook itself, because it is actually, the kernel has frozen user space. So that's still something we definitely want to support for users even before real sleep mode is implemented. And all of this is going to be required for real sleep mode anyway. So that's pretty good. Jody says CD GPIO seems to be the DT name for card detect GPIOs. Yeah, thought so. Because there's a bunch of controllers that rely on a GPIO for that and don't have an internal one. So that is a bunch of things to be done. Let's take a look at that. So first, let me test SMC, because if that's broken, that kind of throws a wrench into all my plans. And all the other, power save restore stuff is relevant for sleep mode, but it wouldn't be useful for a card insertion. So let's give it a shot at that. Proxy client, tools SMC CLI. What GPIO is that? Apple docs. I need my. This is why schematics are great, by the way. Like, I know it's just leaked, but like copyright-wise, there's no real threat here, because we're not like copying, like copyrightable things from the schematic. But having this is what lets me know that there is the GPIO 7 that in fact is the card detect, even though Apple doesn't use it. And so this kind of thing allows us to support the hardware in the way it's designed, which is not necessarily the way macOS does, and which means we can do things in a more Linuxy way, or just in general a better way. So that should be GPIO 7. It should support interrupts, hopefully. So read 32. It's not read 32. Is what is it? What's this called? I forgot. Oh, wasn't it call, or how do you call that? No. Funk. SMC EP. Oh, sorry. It's like that. Yeah. It's RW32, yes. And I need to see what these commands were because I totally forgot. Drivers, GPIO, Mac SMC. There we go. So action is 0, output is 1, input is 2. Let's get RW32 input, which should be 224 like that. GP07. That says it's 0. Let me get an SD card. And it is 1. Okay, so the GPIO is in fact working properly. Now let's test interrupts. And by the way, the SD card controller is powered down right now because we have just rebooted the machine, so that proves that this whole thing is working as intended. And now I need to turn on interrupts, if I remember how to do that. Interrupt enable is 4, so write 32, 4, IRQ mode, and we want to trigger interrupts on all interrupt changes, so it would be 4. So 424 type 4. And that gives me an event 7-1, which means pin 7 changed to 1. And if I pull it, nothing happens because I think we need an ACK on that. Oh, wait, no, I need to actually do an op, don't I? There's that. RW 32, 224, yeah. Yeah, it does. Okay, yeah. So we do get the events when it's turned on. Unplugged, unplugged in. It is possible to use high and low, and then it will, like there's a reset sort of function you can you can use to get it to re-trigger next time. So we'll see if we implement that because it's a bit weird how to do this with interrupts. But in principle, if we support edge interrupts, we would just want to use this rising falling on both setting, and that will basically do the edge thing. There are potentially some race conditions here, though. They can mostly be mitigated, I think, with some like delays if we really run into it, because of course this isn't like synchronized with the controller booting up and stuff. But we can probably make it like as long as the driver potentially polls the GPIO in certain places and does some checks, I think we can avoid races that break the SD card. So that needs to be implemented in SMC first for any of this to make sense. In this driver, in fact. It's a good thing I already had all these defines, isn't it? So let's give that a shot. Now, I need to look at how that works with GPIO drivers. Drivers, GPIO, IRQ. So it does support high, low, falling, rising. And this is an IRQ chip. I also want to see which is the sanest way to do this, because I wouldn't be surprised if there's like different variants of how to do interrupts in these GPIO controllers, and like some are less crazy than others. Because this isn't even chained off of an interrupt controller, because it's like it's going through RT-Kit, so it technically does chain off of an interrupt, but not in an interrupt controller way. And I don't think it makes sense to try to shoehorn in, that relationship as an interrupt controller. Mostly because the SMC events are like 32 bits. They're all about the same length, aren't they? Yeah. So in this case, C5 chip number node parent domain. There's no parent domain in this case. Is there anyone that doesn't have a parent domain? Maybe this one, our car. Let's look at this one. Doesn't look too bad. Not that big a driver. All right. So the interrupt controller gets set after the GPIO chip. So we have a GC here, struct RQ chip. Is it struct RQ chip? I think so. RQ underscore chip. Let's call it IC. And that is already allocated. Is yeah, just in there. And that is a global. That's not going to be a global here. Oh no, it's just a local. Dot name equals. Let's just call it. It doesn't have to be a different name anyway. Okay, so we're gonna need our Q mask. Disable. We need an enable. Set type. Set type. We don't do wake ups yet. In fact, with the way this is currently done in S2 idle, the SMC remains powered on. I'm actually not sure how wake ups are handled. Obviously, there's this lit open thing, but actually, that is handled as a different kind of SMC event, so I don't think we even have to deal with it as an interrupt. So I think we might not need any of that wake up stuff. We do need some flags. And mask on suspend is reasonable for this because I don't think we care about the user inserting cards in suspend mode. Set type masked is what? Is that documented? Of course it isn't. Mask before calling RQ set type. Is that a good idea? That probably is a good idea. That sounds like a good idea. Let's do that. And I think that's all we need. Pretty much. All right. And then What's this GIRQ? Oh, that's the interrupt controller. Oh, GPIO. Oh, right. It's a separate thing. Yes. So GIRQ is, well, it's just in GC anyway, so we don't need to do that separate. We can just say pgc.rq. Is that right? Yeah. Dot chip, yeah. And there is no handler for that because we do our own thing. RQ type null handler. And these aren't level. These are. Depends on what type you set it to. Actually, it depends on whether you set it to. Well, they all are. No, they're all edge, kind of. We come back to the wonderful world of IRQ handlers. What are the different things here? IRQ type. No, sorry, none. Yes. This is always such a mess. Handle level IRQ. This isn't even running an interrupt context, so we don't actually care. It's not gonna. They're all edge by definition, but I think fast EOI IRQ is actually what we want, because that will let us write to that ACK register, which for levels will retrigger if necessary, which is what you want. So actually, handle edge IRQ is kind of what you want for this one, because as we saw earlier, it definitely we definitely get multiple events even without any acts for, or do we? Yes, we do. For edge modes. So that requires handle edge IRQ. Including the mask and unmask. And then I need to look at the code for this to see what callback we need for, because we do need the EOI for the level ones, though. Let me just make sure that the level ones work as I expect. If we set this to high, 0 does nothing, 1 does nothing because we need to ACK it. So if I write to the ACK, which is 5, I think just writing to it will do it. Or not. I need to send 1 there. Oh, it's not doing anything now. Oh, sorry. That's on. I forgot. The mode is 6. The mode should be high. And if I just do like it's nothing there. Do that, and then if I do a write 32 to the ACK, which is 5. Okay, yeah, it has to be 1. So X, if that's true. And it only happens on high, which is what you want. It gets twice because we wrote it once, yeah. And if I set it to low, which is mode 1, we ACK that. Then we keep getting the lows. Yep. Okay, so that works as intended for those. It's just that the edge, well, the edge ones are just edge, so of course they would only trigger once anyway. I don't think I have a poll thing, but actually this is just like, yeah, there is. There's SMC that poll, I think. Work. Or do work or something. Yeah. So that'll do that. Yeah, see. I was just lazy. So yeah, it does work as I expect, which means that technically we want the EOI behavior for level interrupts, for level mode interrupts, and the edge behavior for, not the level actually, we want the FastUI NMI, sorry, FastUI IRQ for some. So that's gonna be a little bit interesting. I have to read the code for that again. Handle edge IRQ. It's also a shame that the interrupt message tells us what state the CD is in, but we can't actually deliver that through the interrupt framework. So that's a bit of a shame. Okay, so it calls IRQ ACK on the chip. See, that has EOI and no mask unmask logic. But then how is it ever going to get back into pending? Wait, where's the mask unmask logic? If the RQ is disabled, what's RQ's may run? No. What's the mask path? IRQ may run disk. In progress. Oh, this also handles simple IRQ. Actually, yeah, that probably makes more sense. We can just do handle simple IRQ. Oh, that can lose interrupts if... Wait, no, it can't, because this is the RT kit is already going to be processing everything synchronously. So there's no way the handler is like there's a work thread, but yeah, okay. So yeah, no, simpler IRQ is fine. Because until the SMC stuff processes the interrupt and returns from the handler, we're never going to get another one anyway. So they all get queued. So that's fine. I think too many get queued, it'll crash, but no wait, no, because we have our own work queue anyway. Yeah, no, that's fine then. Yeah, so simple IRQ is fine. And then for the EOI, we just do it ourselves, and that's it. Which isn't that the same as EOI in that case? Simple IRQ is a sets and run replay waiting. I think it's basically the same. Yeah. So disabled and then no action, and then it just sends RQ event. Handle level RQ. Past the OIRQ. Condom mask OIRQ. Not EOI if handled. Yeah, they're just called as EOI. Okay. Yeah, no, I think we can just use this one for everything then. Because I don't think it matters if we EOI. We can just do it unconditionally even for the edge ones. So it shouldn't break anything. Yeah, okay, let's just use that then. Handle fast DOI RQ. Let's go with that. All right, and now we need the event stuff for our T-kit, which comes from, I forgot how that worked. I should have that in power. Where is that? Actually, input will have it, which I don't have here apparently. Oh, it's hid. No, it's input. All right. Was it under MISC? Yes. Hit event. Oh yeah, we had a notifier thing there. Let's get that. Event. Set the notifier call, and we need to actually call Apple. Yeah, that's how it worked. Register notifier, SMC is there. SMC GPIO, yeah, that should do it. TTMX says, thank you a lot for the efforts. I would like to be buying an M1 when graphical Excel is well supported. For you, there would be a chance of me buying one. Thank you. Yeah, hopefully we'll get there pretty soon now that Lena's working on that. And meanwhile, let's see if I can get the power management in place because people do want sleep mode to work also. SMC hit event. What did I just call that? SMC GPIO event. All right. Mask on substance at that masked. So we need mask unmask. We need EOI. Let's go attack. And set type. And that should be it. So we need to implement these functions. And in event, we need to actually deal with that. So type D1, D2. And those events were oh wait, it's not turned on, so I actually don't know what those events are. I need to tap one. I thought that was ntap. Oh, is it right 8? Yes. And then let's set the mode to one of the easy ones, both. Yes, so that's the notification. There you go. 7202. Which makes sense because it's the one we were missing from in between the HID ones. For some reason, it's HID even though it's totally not HID. I don't know why they stuck it in there. Who knows? Apple. All right. and we return notify done. That's okay for when it's handled. So when we get the event, then we need to go to an interrupt. Oh yeah, and we're also gonna need the all the mapping stuff, aren't we? How is all that done? There's more than one, right? You set type, set wake, interrupt input mode, enable. Where's the interrupt handler? There. Okay, this is good. Yeah, direct domain handler interrupt. And this is IC. We call that. Yeah. Domain. IRQ domain. Wait. PC IRQ domain. Pin. Actually, how do I call the pin numbers before? Offset? Yeah, okay, so offset then. Yeah, I should do it. Very simple. All right, now just implement these 4 functions, and that's pretty much all she wrote. Let's go. Those have to be, what are the prototypes for those? Let's just steal those from that. You don't need set wake. We do need enable and disable. And EOI, which we don't have. But I think it's just like that. And I need to get the GPIO chip and all these things. Struct SMC GPIO. And those go with, yeah, just get data. So it's the same as those. All right. So for enable, we just, well, first of all, for init, do you actually disable everything yet? You probably should be clearing interrupts. I don't know if it do it for us, though. It might. Probably will, though. So for that, we do a write 32, and it's basically just this. Yeah, I gotta rename them still. This is SMC GPIO. Just do a full replace. I have to enable 1. We do need to get the keys, the same as all the others. And the offset comes from... Oh, hold on. Oh, yeah, it needs to be RQ to HWRQ. And those offsets are usually called what? I just do it like that. Doesn't need a new line for that. So that needs to go in all of these. RQ enable 1. Let's get it to compile on the first try. Let's try. So this is void, so we just get to print the dev error, and that's all we can do about that. Disable is the same thing, just with a 0. And we don't have a value on that. We don't need to print the value. Okay, and then for ACK, it's these are really just only the same function. ACK, RQ, ACK. And then for set type is when it gets interesting, and that's just remapping these though. Q type sense mask, and we're going to support all of these actually, because it's a direct one-to-one mapping, which is excellent. Mode. Hi. ACK does need a return value. Wait, I don't know if it does actually. EOI probably doesn't have one. Let me check that. Q chip. Is that described anywhere here? Yes. It's void. There we go. And then we just write CMD. And that was just X, key, CMD, turn ret. All right. I think that's pretty much it. Type sense mask. I'm going to need some includes for that. Interrupt. I don't know if we need both of those actually. Probably. I think that's it. PTMX says, I know very little about low-level computing. Would something like Rosetta be possible in Linux? It already exists. It's called effects. It doesn't like it's not as fast as Rosetta yet, but it's getting there. People are working on it, and we will add support for the M1's helpful features once that's in the kernel, which is not actually that hard. So yeah. All right. I think that looks pretty good. Let's see how many compile errors I get. Let me do a reboot on that. And that is the right one. Definitely got some compile errors. This is going fast because it's T-cached, by the way. So what happened there? Ret undeclared, yes. And also unused value, yes, because yes, we need all the rets. Actually, you know what? Because this isn't returned anywhere. For these, we don't care. For the others, we do, but not for these. Less than 0. This one does need fit. Yeah, this is a box 64. I've been mostly following and what else is there? Incompatible types and SMC IRQ chip. Needs an AND on that. There we go. Just out of curiosity, will this work without these headers? It will. Definitely not without that one, though. Oh, it will. Probably because something else already includes it. Let me just look real quick, because I don't want to cause more trouble for who was cleaning up the headers. Interrupt.h. So we do need IRQ chip. Okay, IRQ chip is an IRQ.h. And I think there's maybe nothing here that we actually care about. Yeah, this is all like the low-level IRQ stuff, which we don't care about because you're not requesting interrupts. Yeah, and I think it was reasonable like that because it's not a hardware interrupt. So there we go. Yes, Ingo Molnar. And this is not actually going to do anything right now because we're not actually calling. I mean, we'll see if it boots, but like if it explodes when registering things. But yeah, no, like we're not using this for anything. So obviously we will test this when GPIO, SMC GPIO, first GPIO key, power events. Yeah, that worked. I don't think we got any weird messages or anything. Nope, that's fine. Also, I'm going to clear back. Yep. Okay, so yeah, we can't actually test this without supporting it in the SD card driver, but that's done. They support TSO, and they support splitting out input and output rounding modes, which SSC2 requires. That is also already an official ARM feature in future ARM specs, but Apple implements it in a proprietary way because it was before it was standardized. Um, so yeah, the annoying thing is that these are proprietary features, so there's going to be bureaucratic issues upstreaming that. But it's not a big deal to have a patch for that downstream, and it's just a performance thing. It doesn't actually mean that your like things will still work. And once we try it, if we can say like, look, it makes this Windows app 10% faster, or this Linux x86 app 10% faster, then that's a good argument for telling upstream to just suck it up and let us throw in some proprietary feature support, because it really does make things faster. But yeah, I would expect ARM to eventually standardize the TSO thing too, because it's too obvious, and it's just a bit somewhere that it's really easy to do, and it makes sense. But it's also possible that it doesn't actually make that big a difference, because like the benefit of TSO is that you don't have to use atomics to implement loads and stores. But as far as I know, these M1s have like very very like penalty-free uncontended atomics. So probably depends a lot on the app, how much of a difference it makes. But it's not gonna be as bad as you would think, and as it would be on other chips. And then the SSC one also, that one's probably has more of an impact, because you actually need to wrap your SSC ops in a bunch of nonsense, and unlike loads and stores, which are mostly just the address calculations are different if it doesn't have a performance impact to use atomics. For SSC, you would be introducing extra logic into the like into the math. But also the vast majority of applications don't actually care about that. So, and actually, you would just really need to check the mode bits. Like, I guess you would check the mode bits, and if the app starts using those in an inconsistent way with ARM, you would regit. Like, there are ways of making that not really matter for most apps. So, I'm not actually sure how much of a big deal it's going to be to actually use those ops. It's possible we like implement them, try them, and be like, it's like 1% performance difference. Nobody cares. Not worth using. Because Rosetta is good. Like the team says, how come Rosetta seems to have such impressive performance benchmarks? Because it's good. That's it. So yeah, and because the M1 is good. Like like the Atomics hack on other ARM chips is probably gonna suck. But then you run it on the M1, it's not. It's not nearly as much, right? So yeah, it's the M1 is good and Rosetta is good. That's it. It's not because of like the special features. I'm pretty sure. So yeah, we'll see. This needs more investigation. All right. So the next thing, this is actually not going to be used until the end, but I need to make sure it was going to work. Is the regulator slash D3 code stuff in PCI. So in PCI, I'm going to have to read some of this code, because there is D3 code in here. Yep. Well, actually, no. First, we need a hot plugging. Oh, and also, let me get that LSPCI thing done. Because that way I can include that thing, SD card controller. Where is that? Genesis Logic. This one. That needs to go in the device tree. Might as well do that now. $9755. Also, I'm going to check my phone just in case I got an email. Someone mentioned that the date on my Spain clock was wrong, and indeed, it was, and it fixed itself after clicking it. That's amusing. Just checking some stuff. Oh yeah, the IOMMU patch got added for 5.18, so that's good. That's one more thing upstreamed. Just a minor thing. All right. So yeah, that's that. Actually, no. One thing we can do now is declare a card. Actually, use. I don't know about the interrupt, but yeah, we can start using the card detect here. So let's do that. What was it? CD GPIOs. So at least, how does wait? What about the interrupts though? How does that? Is there a GPIO get interrupt kind of thing to get that? How does that work? Let's take a look. So I don't even know if the PCIe one supports that. Let me go back here. Drivers, MMC. Yeah, see, it's not in the. It's not the PCIe one doesn't support that at all. So let's do that first. PCI.c. And one that does have it. It's not called PCI. What is it called? Is it core? Yeah. That should be in the core, I think. That's funny. This has GPIO headers, but it doesn't actually do any of those. It does set CD wake. So it does actually support wake ups, which is we can do later. Get CD GPIO. Oh no, but it does. Is it just went through the core? Okay, so some of them have. Actually, get CD is fine without the GPIO stuff. Mostly, it's just the power management. Wait, so then it has Merrifield D. So that's the default get CD. Oh wait, this one actually just does. Okay, that's weird. So I guess get CD. Okay, no, yeah, it does get the GPIO first. Yeah, okay, so we can just declare it. It should actually just use it. Yeah. So in that case, can you get something going to a GDB session? There's actually a GDB. I have this hypervisor. Like the hypervisor is can do basic debug like backtraces and stuff. And I can do I can load the simple man and actually get a backtrace. It has some basic debug features, but there's actually a pending PR that I haven't merged yet that actually has a proper GDB stub, and then you could literally use GDB. So that's nice, but it's not. I haven't merged it because I have to look at some stuff. I saw it was using signals in a kind of strange way, and I wanted to see if I can do that a different way. But the core idea looked nice though. I've been actually meaning to do that for a while now, so it's good that someone did it. Just haven't gotten around to reviewing it yet. So don't need this anymore. Yeah, so this the default get CD should be fine. So in theory, if we just declare a GPIO there, it will actually work. As long as if there's any in it, that's done properly. And the way that's done, well, it should because the Intel ones are PCI and have potentially have those anyway. So let's just try it. Let's just declare it here. Let's see, GPIO 7, GPIO active high. And this CD inverted thing, I don't know if that applies actually. Because right now that's setting a magic bit inside the controller to configure the internal GPIO properly. I don't know if that even applies to CD GPIOs. Because this is actually only checked by specific ones and then by core host. Then CD inverted, it just pokes the caps, but that gets in, I think that's an OF parse, but I think we don't even use most of that. And there's a CD GPIO. How far is the end with the GPU? I don't know. I mean, the thing with those projects is that like you can't estimate how like like how much is left until you get there. It's reverse engineering, right? So I don't know. Like she seems to be doing okay. So CD yeah. So let's just see if that works. Sure, because on Intel ones it does, right? So if it said that, and CD inverted is mostly okay. Override active level. And in PCI core, CD override level, that gets set to true on Bay Trail and on some other Intel thing. Okay, so this actually makes sense then, because then this will configure the controller properly, and this will configure the GPIO properly. And then it should actually, then in both ways are correct, and the controller knows what polarity the CD has in case it cares, and the GPIO has the right polarity. Okay. Do I know if she worked on it since her last stream on that topic? I think she worked on it when she was doing that collaboration. Like there was some work in the end. The one in Japanese. Like the end of that is actually working. So GPIO active high. Yeah, okay, that makes sense. Let's see what happens. Let's get a reboot on that. Just a device tree change. I think there's a print on that, so let's see what happens. Right. This states CAI PCI. I should just get something to grep here. Is the HCI controller found? I don't know if that's actually I don't know if that div info even goes through though. I think we can find out if there's owners of GPIOs though. I don't think it's getting used. Because these are just those. Nope, I don't think that worked. Let's see why. Is it CD GPIOs? It should be. Uh, 64. Yeah, no, that should be correct. CD index greater than or equal to 0. What's it? It just gets set to. Okay, is there some? Oh wait, we need Oh, okay, it gets set in specific ones. That's why. So can we like allow? Actually, how does that? What does that text argument do anyway? And there's an interrupt too, right? Which you also need. That's the consumer, yeah. CD index. Why does it call it with CD and without CD? Like, why does that matter? CD index greater than or equal to 0. How do I want to do this? Okay, let me get blame that. See where that came from, because I don't even know why that's trying twice. Okay, there was something going on here. But that got added in the same commit, though, both of these. Okay. Oh, got BIOS stuff. It is a nice commit message. It's also BIOS bullshit. uh, um, okay, I don't want to do this for ACP systems because that sounds like a terrible idea. Like it'll break weird things. But I'm going to make another code path that if it's on an open firmware system, then we can just try the defaults. And try getting it anyway. So how do I check for that? Yeah, that's a lot of backbeat nonsense there. I need to check for that. What was the right way of checking for an open firmware system? I guess I can just check for an OF node. If there is an OF node, then actually, how does that work on the core? The core there is checking. Oh, GPIO get index con ID, and then that'll do some. That'll use that magic, right? Con ID. DFM GPIO get index. Well, that's why CD is used, right? Because it'll do something dash GPIOs, I guess. Yeah, is OF node gets the firmware node from the dev, otherwise from ACP. And OF find GPIO will do like dash GPIOs or something. Yeah, okay. Yeah, so in that case, where's our device? pdev. I think I'll just say .f your note on that. And hopefully that'll handle a null. Not is there null? Yeah. Yeah. I'll buy that. So on pro defer, go to return. Otherwise, if it's 0, actually just set it to 0. Don't need that. Okay, let's give that a shot. Cool. If red is not 0, not pro defer, then there's just no GPIO, and we don't do anything. It just uses the internal one. And CDIDX stays at -1. All right, let's look at that. Whoa, okay, we got a warning. Enabling device, scheduling while atomic. Okay. Ah. Um. Is IRQ set type supposed to be atomic only? Because that kind of sucks if so. You can disable that set of IRQ. Interesting. Is there a way of bypassing that? Spin lock IRQ save. Yeah. That does mean that at least they got the interrupt directly, so we didn't have to specify it manually, which is good. Yeah, I think that's going to have to be atomic. The good thing is we have atomic rights because I needed that for reboots. So yeah, that's good. I guess we can just go do that. That was used in reboot, which isn't even there. Power reset Mac SMC reboot, and that uses right U32 atomic. Where is that? SMC GPIO. There's no RQ chip. Yeah, I think that's the only reasonable thing to do. The atomic one will poll for the reply to come in, yes. Which is okay. I mean, even if we like, there's no real way of doing like this is the way Linux is architected right now. Like it just assumes that interrupts are, you know, in atomic context, all that management stuff. So yeah, not much we can do about that. I do wonder if we need to disable interrupts around the handling, because right now we don't, and that could cause other breakage. Okay. Enemy device. Okay, that didn't say anything about CD interrupts, but it also didn't explode, so that's good. Sys, where was this? Kernel debug GPIO. Okay, we got a CD. In high, IRQ is enabled. Is it gonna work? Whoa, that was a nice explosion, but it did find the okay, and it definitely let's plug it in. Okay, so that's gonna be yeah, that's gonna be the opposite thing, isn't it? It complaining that we're not there. So it did work ish. The initial insertion worked. The enabled interrupts, right? Oh, they didn't handle. Yeah, in hard IRQ. Oh, generic handle IRQ is safe. Okay, yeah, so we're missing the function we need for this, but that's okay. Just kind of open code that. Save. Restore. And then that just needs to do the same thing this is doing. You're not actually handling red here anyway. Let's do it like that. All right, let's try that. Semicolon. That's my UPS complaining about. I think it's probably complaining that I'm using too much power. But like, it does it randomly sometimes. I'm not sure why. I should just get another one. Because this is like, has my servers and my desktop plugged into it. All right. Okay, so the init is fine. I assume it found the card. Unplug it. Whoa, okay, that exploded even worse. Yay. Unbalanced enable for our... Oh. Hmm? Something else is broken here, isn't it? Inbox chance and data calls enable IRQ. Is the mailbox broken now? Wait, why are we unconditionally calling enable IRQ on that? Q send empty. Yeah, so that can obviously, we can queue more than one thing, but I thought we didn't, though. And also, multiple things were running at the same time here. What was running? Now, this is going to be really confusing, isn't it? Oh, right, key atomic, yeah. Because the atomic stuff... I mentioned I hate mailbox already. Oh wait, no, this is I think our T-kit is broken. Like my thing for the sends and atomics, I think Sven lost that and didn't realize why it was like that. Hold on. Driver sock Apple RT kit. Here. Oh no, it does set it to false. Okay, so then that's not it. Are we missing a? I think we're just missing a spin lock here or something. Yeah, because we have two things sending data at the same time. That's why it exploded. And the way that works in mailbox. Yeah, we just need a lock because this is none of this is locked. Um, None of this is locked, and so what's the right place to lock this? Oh, there's a K thread. There's a K thread involved. There's a K thread involved, and that's calling on mask threaded IRQ. See, all the SMC stuff is already using a mutex, but not the atomic one, obviously. And there's two problems here. One is that that event is not going to be holding any locks. And then that calls atomic. Yeah, that atomic thing was never actually meant to be thread safe because it was only used for reboots. And I remember I tried to do that and it got really annoying. So I guess I have to deal with that now. What's the right way of doing that? Is this under sock Apple? No, it's not. Where was that? Was that an MFD? Or MISC? Oh, platform, sorry. It's under platform Apple Mac SMC, SMC Core. And SMC RT kit. I remember I tried to add like a spin lock to this and then it didn't work. And I don't know why that was. Should work. Let's try it. What's the spin lock story? On something that has a spin lock. I think I tried this at one point and like something went horribly wrong, but I totally forget what it was. Okay, let's try that. Mind you, eventually we're probably going to want to support RT-Kit, like concurrency anyway, for performance, especially for the GPU. But SMC does not support concurrency, so SMC needs this kind of thing anyway. Okay, that is going horribly wrong. Preemption disabled, yes. Scheduling by atomic. Yeah, because this... we don't need send message wait. Because that waits for completion. The world sucks. Hmm. Does mailbox use any locks itself? It has a mute hex on request channel. And there's a chan lock. That's around add our buff and submit. You know, there is a lock around send data. Then how did we end up there twice? No, that doesn't make sense. And we still kind of need a lock here, though, because the problem is that like the reply data can be overwritten and stuff like. Well, no, we only use atomic for U32. So that's actually okay. The problem is that the replies could arrive in a weird order. Yeah, we do use the shared memory for this, so that's got to be... Ah. That's going to be annoying. Atomic pending. Because this really needs to be serialized. Oh, hmm. Oh god. Apple SMC probe. Preemption disabled by Apple SMC probe? That's probably just the RTGet read key, yeah. Yeah, that was preemption, but what's the right way of doing this? Here's what I really want is like a hybrid mutex spin lock, right? That like has mutex semantics except for the with the atomic one. Either that or we make everything in SMC atomic. That'd be one way. I don't really want to do that, though. Where was that? There's a dog. It's not that one. That one might be it. Oh, this is like the old one. Yeah, that one. Locking. Okay, now I think the way to do this is going to be to actually, there should be a mutex try-lock thing, and we just need to spin for that in the in that one. That's gonna be the only way. Spin try-lock? No. That does something similar. Oh, but it's per stream, so. Oh, Joey found something. I mean, yes, asleep. Yeah, but this isn't because it's in atomic context. This is just because of a race or something, like deadlock or something. So that's not the same issue. Where is that actually implemented? It says it must not. It says it must not be used in interrupt context, but it doesn't say it must not be used in atomic context. And these aren't actually interrupt context because the events from RTKit actually come from a thread anyway. Let's just do that, see what happens. Delay is a thing, right? Yeah, let's just use the delay. I don't know. I hate it, but let's see what happens. Where's view delay? Linux delay.h. Okay, no explosions so far. Plug in the card. Okay, that worked. Unplug it. Okay, that worked. Okay, it's working. Almost. We still ran into... Whoa, okay. So it kind of works for a while. And again, we run into two things at once. What happened here? We got the event, did a bunch of stuff, tried to mask it. And the other one is also right kit atomic. right key atomic, which came from another key thread. So wait, the lock isn't actually working? BRB. That's weird though. Kind of confused about what's going on here. Also, why is it so cold? Yay. So there's a read key. Oh, did I miss one? No, it's there. Oh, hold on. It's just a bool, so. Huge spin lock slow path. And fast TOI. me turn on some lock debugging stuff. That's going to be a full rebuild. That's going to take a while. Still not sure what's going on here, though, because, I mean, I took the lock, right? Hmm. Hmm. I mean, we definitely have, in theory. Oh wait. Oh wait. This is logs. Yeah, that's gonna be part of the problem. Yep. That's gonna be part of the issue because there's no locking here in this stuff, right? So if anything else calls the calls send message. Okay, then yeah, then our ticket needs this pin lock. What was that? Spin locking it. Yeah. Send lock. Incomplete type. That was in spinlock.h. Hmm. Oh, is it spinlock T, was it? What's the type? It is spinlock T. No, not struct, just spinlock T. Make sure that actually is in the right place. Okay, let's see what happens there. Warnings, but no explosions. Some explosions. Better than before, though. At least this is readable. Debug RWSEMS lock on. Okay. Oh, okay. Blocking notifier call chain. Is there a missing init here somewhere? Might be. Yeah, I think I'm not initializing that notifier chain. That's a bug. SMC core. No, I am. Raw init notifier. Oh. Actually, that might be also broken because this, the handler for this, it goes to receive early. Oh no, yeah, the events do go through the main receive, so that's good. Which means that's already serialized by that fact that that happens in one thread. So that raw is fine, but then these are the wrong calls. It's not blocking notifier, it's raw notifier. Where was that here? What does blocking actually do anyway? Oh, RWSM. Now let's just go with blocking, but then I just need to actually enable it because all of these are in fact running on process context. So I'll just do that. And the other thing that happened, so those two are fine, debugger resistance, and then we do have another unbalanced issue here. So there's still a problem. Okay. So that panicked. Made some nice explosions, two of them at the same time. Apple RTKit TX done. Calls complete. Okay, so there's something with the completions then. TX done. Can I get any nice back traces from this? Okay, that's one. See, this is better than the kernel. And the kernel thinks it doesn't overlay. So what happened is we got an event called the chain. which tried to do a write from the event chain, which is allowed. Oh, wait. And then that. Wait, that died in the format. Oh, hold on. Okay, I know what happened there. That's just me screwing up a printf. GPIO. Where is this? Right key atomic. Or not. Right key atomic does a dev error. Should be the failed to send command one. Okay. Next CPU. 5, 6, 7. Okay, there's one that exploded. 8 and 9. Yeah, okay, so there's these two things that panicked at the same time. So I got a TX done interrupt while in right key atomic, which is reasonable. And then called TX done, which called complete on something. Oh, no, but oh, hold on. That's a nah. It does a send message. And then TX done completes the completion. And then wait calls flush. And then waits for the completion. That's reasonable. Is this a mailbox problem? No, we have flush in here. Oh, because it's also called tx done. Yeah, okay, that's what the problem is. So, because this is still going to get the interrupt. That's the problem. Okay. Um, that's the problem. Okay, yeah, we need another lock-in. Uh, yeah, and this is wrong anyway because hardware sent empty. Um, What exactly do we call flush anyway? Yeah, I guess what I need to do is basically call the interrupt handler. Something like that. Expanding. Okay, so basically do it like that. Only call the tx done and disable on tx pending, and then there should be a bug on here. I think I don't strictly need to lock that, but it's probably a good idea. And then okay, let's try that. Have I had to go in with a scope at any point in the dev process, or is it all from the software side? Almost. Not. There was one time when I was looking at the GPIO outputs with a scope to see what the different GPIO config flags were, but that was still through the Type C port. It wasn't. I didn't even open the case. And also, I did have a software scope I made for the SPI controller stuff and I2C. So I was polling the GPIO registers to see the SPI controller's outputs. So that's pretty fun. It's a software logic analyzer. Ooh, nice. Circular locking dependency. Lock acquire. Spin lock. Oh, is it because TX done tries to get the channel lock and that's probably. Yeah, so I'd have to do restore like that. TX done. So put TX pending in here. Actually, it should probably be what was that called? The not handled one? RQ none? Yeah. Okay. Let's try that again. Okay, that didn't explode so far, I think. Oh no, we did. Invalid wait context. RTK send lock. Did I not initialize that? Here. What does invalid wait context mean? Oh wait, because this is all. Oh, it is a raw spin lock. Why would that be an issue? Oh, is it because this because this could be preemptible as Y, isn't it? In if it were real time. I think this is, Ah, okay, yeah, because there was already a raw spin lock for the IRQ stuff, I think. Where's the interrupt? I think it's a mutex. And then the bus lock. And then it does have a raw spin lock. Yeah, okay. So that needs to be a raw spin lock because this gets called from interrupt stuff. Um, yeah. Where is that? Raw spin lock T. Where was that? Here. Probably be this too. Spin lock in it. Raw spin lock in it. Okay. No warnings there at least. Unplug. Kernel panic. Lovely. Okay, so that's still a completion getting called on something dead. Partially, is this the SMC RT kit? So is this actually, first of all, why is it failing anyway? GPIO RQ disable failed for GPIO 7. Um, failed to send command. And that failed. Maybe because inbox flush failed. Let's try printing that too. Yeah, but an unpreempt RT kernel spin T is mapped to raw spin T, but it's not the same thing. So the checker is still going to check that you're doing them in the right order. Let's see. Okay. That broke in an interesting way. This is totally deadlocked. Oh, it panicked. So bad it didn't even print the panic. Well, that's great. Maybe it was just the serial breaking or something. Let's try that again. Okay. Wait. Complete message completion K-free. That's fine. That's not part of the message, but SMC failed to send command. Minus 62 is what? Yeah, time. That's what I thought. So it is timing out. And I think that's part of the problem, is that this is timing out. And it does a TX tick when it fails, which... Isn't that backwards? TX done does a TX tick. It's in there from the beginning, isn't it? Moves down, chan TX done just calls TX tick. And that actually does get the message with a lock. So that's actually safe to call multiple times. So we don't actually need the lock I added here in that case. So this doesn't need to actually do anything. It just needs to return 0. Uh, okay. So then we don't need that. But if this is going to return... Then we don't need flags for that. But I'm still going to keep the lock, though. And in that case, we actually just want to disable the interrupts in both cases. And just consider it handled in both cases. Actually, txdown can be called unconditionally here. Maybe we don't need the tx pending thing after all. Let's leave it in for now. Just to see what happens. And yeah, that looks backwards. Flush. Have I mentioned I hate mailbox? And the implementation must call txdown upon success, but it doesn't. But then why does this call txtick, which txdown... Oh wait, client txdown, not client txdown, chan txdown. No, it's still txtick. Scheduling by atomic. Wait, what? Another invalid wait context. Inbox send message, chan lock. Yeah, because it's... I guess that needs to be a raw spin lock. Have I mentioned I hate mailbox? Uh... I don't know if it's worse than the USB audio, but it's getting there. Where is mailbox 10 defined? Oh, here. Oh, spin lock T, yeah. There's that. 35. I don't think this is a preempt.t kernel. No, I don't think so. But as I said, even without being RT mutexes, maybe it is. It is possible I turned it into an RT kernel on purpose to like debug that stuff. No, I think that's just where is that? Preemption model. Yeah, no, it's not RT. In fact, is that even supported? It's not even enableable, so no. It is a patch set, but I think like some of it is upstream, but I guess not all of it is yet. Just checking exactly where that is. Art supports RT. Depends on expert too, which is probably not enabled. Yeah. So if I enable expert, and then preemption model, not even yet. Ah, okay. So it doesn't even support it yet. Nothing does. Yeah. So this is not a preempt RT kernel. It can't be in upstream yet. Okay. Anyway. So what the hell just happened here, though? Well, we had something earlier. The invalid way context. Yeah. Reboot that. And also, are these raw? No, these also need to be raw. At least the TX one. I swear, I'm gonna send an email to like replying to Sven's and like Artikit series saying, "Knack, we're not pushing this with mailbox. We're going to not use mailbox anymore." Because like this is just gonna keep being this. And like we're gonna get to the GPU, we're gonna decide we're gonna have to be able to submit GPU commands simultaneously from different processes or something, or something there is going to make everything even worse. What now? Evaluate context again. Does that take the RX lock? Wait. Chan poll data. I just take the RX lock. Yeah, so that also needs to be raw. Inconsistent lock state. In hard accurate on W. tx lock. Okay, hold on. This needs to be IRQ safe. What? No. Restore. Now what? Oh, wait. Okay, at least it boots now. Any warnings? Yes. Invalid white context again. Now what? Pin control. Reg map. That's unrelated. This is an existing problem because it's also going through setup IRQ, and yeah, that's an existing problem, and that's a pretty fundamental one. If we're using reghack for GPIO and pin control, and then there's a set IRQ, yep, that's a Linux problem. But we can ignore that warning. And it still explodes. Still getting two things at once happening, which I really don't understand. Okay, so it's just dying on this pin lock in completion after TX done. Which I guess means the completion was already freed. Did we get any errors before that? The thing is, the other thing I think there's an RT kit bug with the tx done. Send message, wait for completion, try for completion, inbox flush. I did fix that, right? Yeah, I don't need fix if it's actually done. Now, it doesn't declare completion on stack. Ooh, that's bad, isn't it? Because if we time out, it's still going to happen. Oh, yeah, no, that's broken. Sven, you're not allowed to submit v4. It's broken. Yeah, no, that's not a thing. That completion. Because then tx done is going to go and try to complete it after after the fact. Guess what? We need another spin lock. Well, no, we don't really need a spin lock. We need an atomic kind of thing. Like, we need to make sure that that is. Wait, how's the locking on that? If no, we do need a lock. Because TX on anytime might get that completion and try to yeah, we need a lock. Yeah, at least with this API, there's no way of doing this without actually allocating completions separately. Who uses RTGet send message without completions anyway? That just doesn't know. 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 Then can you comment on the intent of this completion API? RTKey EP message. Like the problem is that we can't cancel a message send. That's not a thing. So if the completion doesn't complete, it's still going to complete at some point. Is this used anywhere? No. I think this API should just go away. I think this API doesn't make sense. First of all, because we don't really care about when messages were received. Like they're going to be in a ring anyway. And even if you do like user completion, but like it doesn't make sense to wait. Yeah, like I think the oh, is it? Okay. Let's try getting rid of that. Where is RT-kit? Here. And then in SMC, let's just do send message. Endpoint. Message, no completion. Now, what I don't know is why it's timing out, because 100 milliseconds sounds like it should be enough to do whatever it's doing, but I guess we'll find out if it hangs. I think it's a 916. Oh. Okay. That's the one from before, isn't it? Yep. Okay. Did I fix it? Is it stable now? Let me try to be evil with this thought. Uh, well, it gave up on that. It didn't hang though. I don't know if that's because it actually um, hung or does this still work? Oh no, no, it's broken. It's broken because I'm not getting the power button events. So something went wrong with RTKit there. Am I gonna? Nothing blocked. Oh no, RTC set time SNC read. Okay, no, yeah, something is blocked there. Yep. I see preempt detected stalls. Yep. Hold on. So task states. RTKit RX work. That looks like a lot of RX work. Oh yeah, because I've been hitting the button. Right. Okay. So something is blocking the RTKit thread. There we go. Why? Why would a spin unlock preempt? I'm confused. SMP call function single? Oh, SMC read. Okay. Yeah, no, that one's expected because it's blocking on the SMC, but that's probably just because that CPU is blocked, but yeah. Oh right. Okay, yeah, some CPU is broken. And I can't see it because it's broken. That's the problem. Thankfully I have a hypervisor. BT 1, BT 2, BT. Okay, CPU 2 is blocked on IRQ finalize one shot. That's interesting. CPU 3, 4. Mac SMC GPIO event handle IRQ this right atomic. Okay, that's stuck on right atomic. That's stuck on right atomic, which is stuck on. Oh yeah, okay, we're gonna have that problem, aren't we? And that's stuck on the RTC time, isn't it? No, but RTC, yes. And the RTC is stuck. Why? No, that's just a mutex lock. I think now it really. Oh no, wait, it's Whisperer. Okay, so something is holding the mutex. And is waiting for something. Okay, can I do the task states again? That one's just stuck on the mutex lock. Okay, that one's in RW. That's the one that's killing it. And then that's doing send message. And then spin unlock IRQ restore. Claims to be running. Oh, I think it's trying to migrate to another CPU, and that CPU is stuck in the spin lock. Not the spin lock, something in the spin loop, I guess. Because that's in atomic context. Ah. Yeah, okay, that's gonna suck. Okay, so that idea with the locking the mutex as if, yeah. How the thing is, I can just make all of SMC atomic. Well, anyway, we already introduced the send lock in RTKit. So at least it's not going to explode when doing that, even if you call this twice. So that much is okay. And now the tricky thing is going to be that okay, I have an idea. I think the ID can just be whatever I want. What if I give atomic SMC messages their own SMC ID? Which means that one's wrong. This has to be here. Oh, wait, no, but then I still have the problem of the shared memory, which I can't. Eh. So you don't need to do writes, but for writes we need to use the shared memory, and that's a problem. And there's no way to point it at a different place in the shared memory to only use that for those messages. How the hell does Apple handle this in macOS? I guess maybe they don't need anything to be atomic in that for them. SMC. Yeah, that's not helpful because I can't actually overlap them. Those low bits there aren't some kind of offset or anything, are they? I'm just gonna proxy client mini firmware. Where was this? SMC. If I just set this to like or maybe the sizes have no. Nah, that's not doing that. 15311. Yeah, those bits don't do anything. Nah, there's no place for an offset like that. Nope. Oh wait, that didn't actually work. Oh no, I did pass a 3. Yeah, no, I did. Yeah. Yeah, no, there's none of that. So, hmm. Hmm. Is there a same way of handling this? As if, yeah, no, we do have to wait from atomic context on, and if already handling is not atomic, it's just not gonna work. I can only think of making everything atomic for SMC. There's if we can do it, yeah. I mean, if this is pinned on one CPU and there's a whole bunch of non-atomic stuff that can happen on another CPU, that there's no way to do that without a deadlock, I think. Um, yeah. Well, the GPU doesn't have to be atomic because there's nothing atomic about it. I'm saying making SMC atomic, not making all of our TKit atomic. Well, the cons are that we block. Wait, where exactly did that hang on the? Apple license read mutex lock. No, that one's fine. The one that yeah, this is trying to go to a different CPU. That's the problem. It's trying to go to the CPU that is No, wait. This is waiting on the mutex. That one's fine. The one now I'm confused. What exactly happened? The one that has the this one was processing an SMC event and got blocked on the right atomic. So which is the one that actually did enter the no, okay, now I'm confused. There was something else. Now it's locking on the interrupt path. And then this is handing an interrupt. So this is handling an interrupt, trying to acquire the lock. Okay, then who owns that lock? Because this one doesn't. Okay, no, then I'm confused. I thought the RTC owned that lock, but it didn't. SMC. No, that's waiting on the lock. This one owned the lock. This one owned the lock. And then this one was trying to switch to while owning the lock. That's the one that deadlocked. And in particular, it deadlocked after the spin unlock because it tried to schedule going somewhere. That is blocked, waiting on this. Yeah. If I pin the CPU user, no, because nothing's going to. Yeah, because anything can get stuck trying to go to that another task that is waiting on that. Nah, that's no. No, I think just everything has to be atomic. Just set atomic pending and RTX is the same. Then we just do that. CMD ret. Yeah. Do that. Git. And then an SMC core. These wouldn't be a mutex anymore. Well, at least no, the mutex can stay. The mutex can stay. It's just we also need a spin lock. So that at least if multiple things are fighting for it, only the actual atomic ones will that could be done in RT-Kit. In let's see, RT-Kit. Yeah. Lock. And then just couple. I need like some time. Something here. Should this be in here or should it be in the core? Probably in the core, to be honest, because yeah. Usually it should be there like that though. Let's try that. Raw spin lock init. And it's been locked, right? Or not? Or not? Okay. That's in SMC RT-kit. Okay. Oops. Oh, I forgot to set it to atomic. That. And then I also should actually make those in the core. I should actually make it basically so that if only the backend, because then this is not going to be needed for like the Intels when we have that. Actually, I should just say should just do that, to be honest. Oh, and then I need flags here. That's kind of annoying. I think that needs to be a defined because flags is not passed by reference. Something like that. No, wait. The atomic one does have to be like that. Actually, the atomic thing is going to be different anyway because the yeah, that isn't actually needed anymore. It's just that if we're using a mutex most of the time to avoid, spinning CPUs, we would need a flag or something. Might change how I do that, but at least now let's see if it works. That's the same one as before, isn't it? No, it's not. In that way context. Wait, did I reboot? Came in cache lock trace. Didn't I fix that? Came in cache alloc trace. Key calling CMD, calling send message. Did I miss something there? Oh, there is locking. This is save, restore. Call send message with atomic. Is it because GFP atomic? Oh, okay. We can't allocate in raw spin lock context. Lovely. um. Okay, if we're in atomic context, then it actually makes sense to wait. Um, so in that case, Try that. Completion is 100%. Okay, what now? That didn't go well. Oh, I forgot to if freeable. Where is that? What now? Kernel bug, send message. Get direction RW. I get the feeling this inbox flush isn't actually like working properly. Like the timeout. Now it worked. Another invalid wait context. That's atomic. It's holding RX lock and it's did that have to be yeah, because Because the poll one has to be called from interrupt context, and that means that then we're calling that one from interrupt context, which means that's getting also locked. But actually, I can fix that one. I can fix that one by not using this one. In this case, the worst that can happen is that both enter poll data, and it'll just write. Yeah, no, it's fine. That's fine. As long as only one receives a message at the same time, and yeah. Oh, but then both can call inbox and receive data at the same time. That could be a problem. No, it's still a problem. Because then our ticket could explode. And the ones that can't allocate. Where is that allocating? Our ticket RX. No, that doesn't work. And that is pulling init work, queue work. No, this case the alloc. Okay, I don't think I can fix that one. And this is still broken. What now? Is it just a bug and send message? Okay, that's obviously broken because I set the timeout to 10,000. So that's not working. The bug is in line 617. Yeah, so it claims it returned fine, but then completion is not completed. Even though that definitely should have been completed. Mailbox. Oh wait, because flush. Try wait complete. It's because ah. Hold on. I first need the return check there. For send. Okay, try that one. Okay, now what? Okay, that's the reg map one. We know that one. That's fine. Okay. That's unbalanced enable. Okay, that's flush calling tx tick. At least it's not crashing. Definitely have something broken with the interrupts, but at least it's not crashing. I can mess with it. It's stable. So okay, this has got to be something dumb now, right? It's something dumb here. TX pending. Yeah, I think I just broke the logic for that somewhere. It's set to true, enable RQ, TX pending is false, calls TX done. And then It does call disable error queue. And flush sets pen DX fitting to false, but doesn't. Oh, okay, that's why. If it's empty, locks the TX lock. Also, isn't this broken? Because there's something else sends. Well, nothing should be sending though. That's just so the interrupt doesn't fire. And then that. Oh yeah, that's because that will. Yeah, that's why. So then, if TX pending, turn it off, disable RQ. I think it works. Finally. And like you're not exploding or anything. Yeah. That didn't. Oh yeah. Okay. So there's some. There's a race in the SD card driver where if it gets an interrupt like too quickly, it doesn't initialize it. I should look at that later, but I mean it basically works. In worst case, if that happens, just pull it out and plug it back in. It's not a big deal. It's basically working. Okay. Yeah, power plant should work fine. Okay. I hate the state that this is in right now. This is like there's the SMC having to be atomic is unfortunate. I'm going to ask some IRQ folks what they think about this because the cause for this entire mess is that the entire IRQ management path is supposed to be atomic, and now we are tunneling IRQs through a freaking coprocessor. But if we need to make everything atomic, I'm fine with that. But I am seriously considering ditching mailbox. This is kind of ridiculous at this point. The amount of horrible stuff we have to do just to make mailbox play properly, and it's not even doing anything for us. The queuing is like we don't need it. It's making it hard to use the FIFOs. It's going to be more of a pain when we add more multiprocessing. I know I hate it. So I'm first going to find out whether we really need to do everything atomically for the interrupts. And if we do, I'm going to suggest we delay this whole RT-Kit merge thing and ditch mailbox because just no. Even if we keep the bindings, I don't want to use the driver, the framework. So anyway, that's what I've got. I think that's enough for today. That was a lot more annoying than I expected, and I didn't even get to PCI at all. So yeah. Uh, I think I'll see you all later then. I'm not happy. Yep. Bye.